Oh, this is my project. I use this to replicate the Volvo braking system. What the Volvo braking system is as a car is approaching an object, after a certain distance, it starts slowing down. So there's a lot of safety involved for both the drivers from the front and the rear. So as a car is at a certain velocity, as it grows closer to the object, it starts slowing down faster and faster, and it eventually stops so that it doesn't hit the object in front of it. Similarly, I applied that concept to this vehicle. This vehicle is powered by a 9-volt battery for the Arduino, a 9-volt battery for the front motor, a 9-volt battery for the rear motor, and the front motor has a gyroscope sensor and the rear has an ultrasonic rangefinder. Using all these concepts, I could code this and get this all to start working again. The rear motor is actually quite powerful since it has a 9-volt battery, and they both are direct current motors, DC motors. So I don't want to turn the rear on right now because the axle will propel forward really quickly, but the front one can be easily turned on since it just goes left and right. I'll give you a quick demonstration of the front view of the vehicle. I'll quickly tell you what components are in there. I'll bring this a little closer. Right over here, as you can see, that there's an LED where my finger is pointing for the right side of the vehicle and one on the left side of the vehicle. And right in the middle is the MPU 6050 gyroscope. And the ultrasonic rangefinder is right over here, right in the front, so it can detect objects in front of it. So a quick demonstration on how the left and right indicators work and how the moment that light turns on, the motor in the front will turn either left or right. This is helped by an H-bridge. The H-bridge helps reverse the polarity so that it can turn left or right. Because it's a DC motor, DC motors can only propel in one direction. So what the H-bridge does is it actually reverses the polarity so that it switches either left or right. So a quick demonstration. So as you can see, this light lit up and it turned to the left, and then adversely the other side. Straightens that first the moment it's completely parallel to the ground, and turns to the right side. If you notice that these lights actually lit up, the moment it lit up, it turns in the direction. The rear is powered by a motor also, and it's powered by a 9-volt battery which powers the motor in the rear. As the car approaches an object, it starts slowing down, and the moment it's going further away from it, it starts speeding up. So I'll turn the rear on. This may make a lot of noise. As you can see, it slows down the moment I put my hand in front of it. The moment I remove it or move it further away, it starts going a little bit faster and faster. And that's the quick demonstration. And there are a couple other things I want to point out over here. At the very center, there's an H-bridge, which is located right in the middle, like right over there. And to the left of that is a transistor. The transistor really helps. It's really hard to point out, but see if I can get it. Yeah, I think you might be able to see it now. I'm pointing right to it. So the transistor really helped out because you can't exactly use the Arduino to rely on its 5 volts of power to supply to the batteries, because it just won't rotate, and especially with the weight of the vehicle, it'll be really hard to do. So what I did was attach the transistor, and the transistor can help amplify the voltage that's being supplied to the motor, so therefore it can propel faster. The power to weight ratio was really different from what I began with at the 5 volt. The 5 volt battery can only do so much, so implementing a 9 volt battery into the motor really helps out when it comes to the power weight ratio. And that's about it.